Good morning. Welcome to lectures 32-33 on thermodynamics of materials. We are discussing the second law of thermodynamics, and we got that general statement. What is the statement? Just the second law. Thermodynamics. What is the statement? I gave you in one line. ds universe greater than equal to 0. Equal sign is refers to reversible process. Process or equilibrium process, and inequality sign greater than refers to the reversible process, irreversible process, or spontaneous process. Irreversible or spontaneous process. And you may note here that less than sign, which is not included, refers to impossibility. Refers to the impossibility of a process. And what is ds universe? Note, ds universe is ds system plus ds surrounding. So this we discussed last year. We formulated this. We kind of formulated and tried to derive this. This we did. Okay. And what is this? Recall two important. Also note two important also recall better means I have already discussed two important relations. What are these? ds system is what? Hello. ds system is what? I gave you last year. dq reversible. Let me write. dq reversible by t. This T system. This is actually T system. That is, T is T system. Yes. T is T system. Obviously, when we say pressure, volume, temperature, that refers to the system. And ds surrounding is minus dq, not the reversible specifically. No. Not compulsorily reversible. It is Q process. Q process means it depends on the process. If it is reversible, then it is reversible. If it is irreversible, then irreversible. This I discussed. And T surrounding. It is better you can write here. Since I am writing this way, T surrounding. C surroundings. Okay, it is better I write here instead of this. It is better you write here to have this dq reversible by T system. Okay, this actually we discussed all these things. So let's start from this point. We want to establish this. Let us today verify for satisfaction that whether this second law statements works with some standard processes like isothermal process, like adiabatic process, like constant pressure and constant volume process with n moles of ideal gas, then we will be kind of convinced that okay, this statement is correct. Okay, we have already proved, but further. So let us today verify the correctness or of the statement, second law statement. What is this? DSC universe. Today this is the job we will take up. Take isothermal process. Start. First example. Isothermal n moles of ideal gas. Isothermal, which is very well known. Isothermal expansion I am considering of n moles of ideal gas. Of n moles of an ideal gas. Isothermal expansion of n moles of ideal gas. This is actually our, so reversible I consider. This is well known to you. I consider first case reversible. Means reversible, you know this process very well. You know this process so well, so reversible as well. So I will start quickly then. I follow DS system. DS system I consider is what you will say. Tell me. DS system is dq reversible by T. Reversible by T. What is dq reversible? You know, actually is also dw reversible by T. You know, because shall I write du plus dw? Sorry. Okay, you know, du plus dw reversible by T, and du is 0, you know, for ideal gas isothermal. So what is the dw reversible also is well known to you. P dv always by T. P by T is nr by v dv. Okay, nr by v dv. The surrounding is what? The surrounding is what? Tell me. Minus right dq process. Okay, by the way, you can write here T is what? Right here. It may help you. Just in this case, there is another term T surrounding, so it is better to write T system. This T is always, you know, PVT, always referring to system always. So PV is RT. PV is an RT. So P refers to the system, V refers to the system, always. So it is redundant though, but just we maintain this. P by T is NR by V. Okay, P by T is okay. dq process by T surrounding as I follow this. Okay, this was discussed last day though, but remember this, I am giving this minus because, you know, as I told you, because if system absorbs it, gets it, the surrounding loses it. So the opposite sign always. If surrounding gets it, system loses it. So opposite sign. And dq process I said because surrounding is not, see system, it must be reversible compulsorily. Okay. So dq process will be what shall I write? Tell me. Since process is known to be here reversible, the process under study. So T surrounding I am writing once more for you. T surrounding I am writing. Then next line I am writing minus dq reversible by T surrounding is what? The isothermal process T is isothermal. T surrounding is T system. Come on, T system. T surrounding is T system. Okay, huh? So you see, you can see. Okay. Hence, you don't have to go all the way. Since You can go all the way here, okay, T system. So ds system plus ds surrounding is actually here. You can see this. You don't have to proceed further. You don't have to proceed further. You can write here. This is not written maybe. This is okay. Okay, anyway, you can see, check this, okay. This is dq reversible by system. Achha, I'm writing for you. Since system minus dq reversible by T system, giving you what is 0 as we expected. So verify it. Irreversible process. The same thing you take up, irreversible. Achha, it is better to sketch you, and then it helps you more. I'm sketching the reversible and irreversible, which I have drawn million times already, but once more. So this is your reversible expansion. 1, 2, maybe A can be given. Reversible, which I have discussed, yes, which I have completed. Irreversible can be, there are numerous or okay, infinite number irreversible, but commonest is against the the final pressure, as you know, 1A2, 1B2, okay. As you do this double arrow, this is reversible, this is irreversible. Quickly, irreversible I will write it. DS system is what? DS system against phase. Forget this, then start phase. What is DS system? What shall I write? Tell me. What shall I write? The process is under irreversible. Right here O1B2. Right here O1B2. And reversible right here 1A2. So you specify corresponding to the drawing diagram. So what shall I write? DS system. I told you this. What should I write as DS system? Irrespective of the path, it cannot be violated. DQ reversible by T. This is actually we have found. Okay, DQ reverse. That is the very definition of DS system. DQ reversible means in reversible process the value of DQ that you have to link up with the DS system in an irreversible process. Very interesting. That you have to. No violation. Then second law will be disturbed, because second law will be violated also. Shall I write T system? Shall I write? You don't mind I was. T means T system. T means T system as unnecessary over. That means same as before. The same as, that is the same as what? Tell me. DS system, tell me, in the reversible path. In the reversible path. Follow this one, this statement you follow. What you say, you will say first. Anytime you come across this situation, you write this or don't write. You will say, sir, I am not so much concerned. Between same initial and same final, this value will be independent of the path, because it is a state function. And that entropy is a state function we have proved last class. Okay, last class all introductory things over. The entropy is a state function. Right somewhere. Also recall. Come on in. Note. Are you right? Note. Entropy is a state function. Is a state function. This is additional statement. These are the important. What I have written here. These are the important observation last class. Okay, I summarized it. This side is summarization. Okay. This is the summarization. Last class. Last class. Okay. This okay. Summary of the last class. We may say. Very good. Very good. So what is my argument? I say I am not so concerned about irreversible. See, entropy is a state property, and entropy is very well defined in the reversible quantity, namely dq reversible. So find what is the value in the ds is actually in the reversible part. The answer is this. If you want to delta s, just integration of this. That I will do later. But it is easy. Everything is available. In fact, I am giving the answer. If you want to get the delta s from 1 to 2, the integration of this, and everyone knows what is the integration. nr outside, nr ln V2 by V1. In fact, this is the entropy change from the state 1 to 2. I don't consider, I'm just still confined to ds. I'm not considering delta s. ds is what? You see, as you clearly see, is this. This you follow this. dq reversible by T system, and this is also, it cannot be different. You don't write ever irreversible. Then all screwed up. Total second law thermodynamics is totally violated. So ds system is dq reversible by T system. In fact, then what it will be exactly up to this point. But I'm not writing. I'm writing this one. This will be good enough for us. dq reversible by T system, because same as. Okay. So see, you see, but why this? Why? Because right here, because entropy is a state property. Does not matter which way. Same. See, once I have found for reversible, I will apply that same result for the irreversible. Why I apply? Because same initial, same time. So state property. Because entropy is a state function. Is a state property or state function. So here all set. So this you follow. Can link up with that. Suppose you are asked what is that this? You say I cannot. dq you get dq here, but that's a irreversible dq. No, sir, I cannot substitute in the expression for ds system. System requires ds system requires all dq process. dq reversible. I'm very sorry. dq reversible. Whatever may be the path. Now ds surrounding is what? And here actually you have you have to be careful. What I'll write here? dq, follow, dq, what I've said? Process, always process. Surrounding process, then look up what process you are discussing. Which process you are discussing is the irreversible. So you have to write this time process. I first to write process, since you are beginning with this T surrounding. T surrounding. Shall I give us this thing here and to this left hand side? Or that is ds surrounding is then is what? Minus, what is the process? Irreversible. You write irreversible process. Irreversible. T surrounding. Please tell me what is this? Minus dq irreversible. Now for some, okay, you write this. T surrounding. dq irreversible is what? Now work with this. In terms of work. First law. First law. Anytime and every time first law. dq irreversible, tell me. du. This surrounding opposite irreversible, remember. No, don't write the reversible. No, that's no, because surrounding is not system. Surrounding has not the same status as system. System is a special status. For system, we have said, okay, change in a state property irrespective of path. This doesn't hold for surrounding. So this I discussed last day, because surrounding is special case. Don't worry about this point, consider. So what I write, dq, the way I wrote. du plus dw irreversible. Shall I write here? dw irreversible by T surrounding. T surrounding. What is du? So follow this. This is the path. What is the first surrounding? Consider the path directly. Path. This O1, B2. Okay. What is du? Come on in. What is the du? What is the du? because I gave an arrow here. Okay. Zero. Sir, isothermal, sir. And ideal gas. So reversible, irreversible cannot change. That is it. Can it change ever? So zero, sir. So okay. Thank you. So anyway, you are correct. Is minus. Shall I continue? Is minus dw irrev by T surrounding. I start from this. Again, I give a double star. Okay, double star to complete this. Okay, the minus, na? Is minus. There is a minus at the beginning. Minus dw irreversible. It's okay. Actually, let me write. Shall I give a double star here? Double star to complete this. Now, what shall I do? I don't want to disturb this figure. In any case, what is this? This part is over. Reversible is over for you. Reversible is over. We have demonstrated. Okay, what? Let us today verify, etc., etc. These lines I am removing. This line I am removing, and double star. So double star. You follow with me. Then you want to say, dear surrounding you have got. Your system is there for the reversible path. Let us do. Hence, dear system plus ds surrounding, which is ds universe actually, is what? As we get here, right? Copy this. What is this? Ds system is what? dq reversible by t system. Let us write it. Let us write down dq quickly. dq reversible by over t system. Oh, by the way, another thing I made a mistake. I am incomplete here. Can I double star here? Na dw. Achha, t surrounding is what? Okay. It is better I complete this here. Shall I? Okay. Shall I write here? This single star is given somewhere here. And complete this is minus complete. Then you double star from this point. dw is reversible. Return. Irreversible. No problem. What I want to do? Tell me. T surrounding will be written as before. Isothermal process. Thermostat. System. Same temperature. So T system will be convenient for comparison. T system that I will put up there. So what is D surrounding? Right nicely is what? dw. dq reversible. Okay. I am taking time. So dear sister, I am not writing dq reversible. I am writing this step. Yeah. This I am writing. This one. Okay. For the helps for the comparison. dw. Okay. Reversible. Follow dw reversible by t system. This line I have picked up, and minus plus minus actually plus minus means plus then minus. What is this? Right nicely dw irreversible by t system. Shall I can remove these lines now freely. T system then quickly is dw reversible minus dw irreversible by T system. What is this? By T system, okay. dw reversible at the same, which is isothermal process and adiabatic reversible work is always greater than expansion. When it is expansion, positive, etc. So positive quantity, positive by T system, which is positive, again positive. So write a note here, since dw reversible is greater than dw irreversible in isothermal, but you know, understand? Isothermal adiabatic I said. Can you remove all this? So demonstrated. This is ds universe. ds universe is what? ds universe is greater than 0. Greater than 0. Is it refers to irreversible? So established. Second law is verified. For reversible verified to be 0. For irreversible verified to be positive. This is clearly, this is all that is this is actually ds universe. So the second law verified. This is ds, and what is ds universe? ds system plus ds surrounding. So the second law verified. So the second law is verified to our satisfaction. So the second law is verified. Over. First example, I have, maybe this is very convenient to us. So maybe say another example, second example. Start. Second example is constant pressure. I will take 3 examples. I will take 3. Constant pressure and then adiabatic. Then we will be fully convinced that this universal law is an universal law. No, it has been proved already. Second example. Second example is constant pressure process. Constant pressure process, again with n moles ideal gas, which we know, with n moles ideal gas, as system, you know, moles of an ideal gas, as you know, the system. So start, I am sketching for this, for reference, always for reference. Remember, PV diagram, constant pressure reversible, first of all take up, you know very well what is the constant pressure, just flat line. 1, 2, you know, this, and irreversible I will also consider. You remember this, but I will take up this. Okay, let me finish. Remove all these things. This is the last day's discussion. Remove all this. This all. I am writing what is this? This is last day's discussion. Summary of the last class. Last class. Oh, sorry. Summary of the last class of the last class. Let's start this class. Start. What will do? DS system, DS surrounding, all such things. Start, constant pressure process. Start here. DS system. What are you going to do? What are you going to do? This small statement. Small, very small. Rules the universe. Rules. I told you at the beginning when I was discussing reversible process, introducing the reversible process, I said by thermodynamics we mean the second law of thermodynamics. The whole this remaining discussions, remaining classes, all lectures is actually the second law of thermodynamics directly or its very ramification, also branches. Whole the 80 classes say, second law. At times you will use first law, as you are doing here also. First law, dq is du plus dw. We cannot afford to, but by thermodynamics we mean the second law of thermodynamics. And what is the essential thing about the second law? Distinguishing between reversible and irreversible. Say, is it not true? Reversible criterion in one line whole thermodynamics. This is the central theme of 80 classes. This much. Even it is shorter than the first law. Shortest first way, that is also an relation, mathematical. dq is du plus dw. This is this short. And this rules the whole universe. So follow, you see, whether a reaction will occur or not, whether heat will flow from one temperature to another temperature, water will, all will be decided by this gentleman. Chemical reaction means, infinite number of chemical reactions you are considering, metallurgical, chemical, chemistry, and other branches. All whether possible. Not only possible, then he says how to make it possible if impossible. These are the achievements of the second law. So this so important is this law. Stuff, DS. So we verify this number of convince, then use it freely. The DS system is what? See, constant. Do this. Write first of all. If anything happens, you write sir T. dq reversible by T means T system. As I have already told you, so I am not wasting time. dq reversible, you know very well what is dq reversible. See the picture I write. What is dq reversible? I can stop there. But if you want to write one line, what is that? dq reversible is Ncp dt. What else? It's ideal that's Ncp dt. Or for any, in fact, since constant pressure dq reversible is dq. In fact, you can argue sir, just dq sir. Why reversible? Because reversible and irreversible are same. In case of constant pressure, pure substance, any sir, iron sir, Ncp dt. Okay, see, as long as constant pressure. Happy? Okay, Ncp dt. So this is fine, sir. So dq Ncp dt by T system, right? I am always tagging this T system because there is another coming, T surrounding is coming. That's why comparison. DS surrounding. Likewise, tell me minus dq process. Process happens to be here. Process, right? Process. Then I write for you minus. Remember, change in minus sign. Very careful. Opposite sign. dq process is dq reversible. Process is the reversible. dq reversible. I am writing T surrounding. It's a constant pressure. Actually, system and surrounding. It is not isothermal, but they are separated, sir. Because remember the process. Do any of you remember how the constant pressure is carried out in case of reversible? Remember T1 to T2 reversible path. Recall first of all. Reversible. How you moving? First T1. Say T1. when the system is T1, both are T1, first thermostat. Then, but you want to get a process, then you want to change, otherwise no. Equilibrium both are. No, I want a process, sir, but in a reversible manner. So what you did, when it is T1 system, this is surrounding actually, thermostat, surrounding T1 plus dt. So when it is T1 plus dt. So difference is only dt, essentially same. T1 plus dt, add with your calculator, T1 plus dt, say 400 plus dt. dt is what? That tends to 0. Back 400. So T1 plus dt, it is not integration dt. That you cannot neglect, but you can. So it is same. So the surrounding is, what shall I write? I can write for you. Anytime T system plus dt. Anytime it changes, but that system temperature also is. Once it is dt, system is now T1 plus dt. Next time it is T1 plus 2 dt. Again dt difference. T1 plus dt, 2 dt at a system. Then surrounding, next phase surrounding T1 plus 3 dt. So always the difference of dt means the same. So essentially no change, sir. This is, I'm writing for you. Huh? Yes? What is this? Washroom? Yes, yes, sure. Minus, then I write what? Since dt is same as, happy? T system, happy? Now, combine, this, target. I'll reach here, sir. Second law. I'll verify. I try to prove it false. Challenging. I want to violate it. I want to violate it. Heresy, they say. Heretical statement I want to make. No, this is not valid. The second law is not valid. Let us say. So, DS universe. So, DS universe is what? DS system plus DS surrounding is what? At these two, you see, up to these two, you see, what? You see, this and this is nothing but both the same is 0. Unnecessary time wasted. This is not equal, this is actually additional statement. The additional statement. Don't worry. Additional statement, NCBDT. You happy though? Irreversible. How to sketch the irreversible? You know how to sketch irreversible always. You sketch how? Tell me. With the color chalk, dotted. So I give a dotted. So right here again 1 to 2 reversible, 1 to 2 dotted irreversible. Dotted, let me give this sign. You know, hundred of times irreversible. So quickly, not very quickly, you know, dear system. So right, this is for the, oh, I'm very sorry. First one is, oh, right here top. Reversible. First case, this is like this. First case, reversible process. Means you give this 1 to 2. 1 to 2. Okay, irreversible. Second case, irreversible. One to process, okay, 1 to 2, okay, we will use 1 to 2 dotted line, 1 to 2 dotted line. For non-equilibrium situations, okay, start. Dear system, tell me quickly, this will be over soon, quickly and very quickly. Dear system, what is this? Again, dear system, irreversible process. So, but always stick to dq reversible by t, don't ever forget. This is by definition. Yes. So dq reversible by t. So you cannot. In fact, you will argue this way, sir. You will argue again for reasons why, sir. I will copy from this. Yeah, say use the word copy. Copy. What is this? In the reversible again state property. Same initial, same final, same value. That is, it works actually. So dq reversible by t system, because as from the reversible, so is dq system, that is DS system irreversible is DS system reversible. DS system reversible. Because entropy is a state property. You know. But if you write this, you will see they are equal also. They're equal. Okay. Anyhow, DS system is because entropy is a state. I already said because entropy is a state function. So reversible process is easy. Irreversible have taken. Now last one. DS surroundings are again right as we know minus DQ process. This time not right reversible. No. What actually means the dotted line. Dotted minus DQ. Tell me DQ process. You write process, but then you write irreversible. Next line. Right minus. I am writing DQ irreversible by T surrounding. Happy? Continue. Can anyone tell me now? This is if I want to compare. It is DQ reversible. This is DQ irreversible. And anyone DQ reversible. This is DQ irreversible. Are they same? Are they equal? DQ yes equal sir. DQ is du plus dw. Du is a state property. Both same. dw is incidentally PdV. Same work under constant same work. So these are equal actually. Shall I? So you know this is actually same as DQ. Same. Okay, same. That is you don't have to write DQ reversible. It's okay. DQ reversible by T surrounding. I have to again start this place. At this stage I have to give a star this side. This side will be. Shall I write here this side? Good idea. Is continue. So DS is I'm writing minus DQ reversible. Okay, DQ reversible, same result. What is the reason? Actually, I can write. Come on. DQ reversible is you can write du reversible plus dw reversible, and du is same. dw reversible is same as dw irreversible. Constant pressure process. Both are PdV. Same area under the curve, etc. You know this, but this part. T surrounding, what shall I wrote? I wrote that time what I wrote. Can you tell me? That time, can you tell me? Incidentally, I have not removed this. It's a good. This is actually, this is surroundings. This is actually, these are the surrounding. These are actually external thermostat. Number of thermostat, that is, thermostat is the surrounding. The surrounding. This is reversible. Achha. You do, oh sorry, I don't have space actually. Irreversible, if you tell irreversible, what is that? Tell me. T1, first is T1, state. Then, a finite, sir. It can be T2. So, what is the general name for this finite chain? Tell me. T1 plus? It can directly T2. Okay. So, shall I write? Star, I have given star. Star I am taking up here. I remove this. This is a good place. Not this. Okay. Star. Is what I am writing minus DQ reversible. T surrounding is what? There is a obviously since irreversible finite driving force or finite change. Temperature must be finitely different. Surrounding temperature at any moment is finitely different from the system. If it are if you are actually same or say only different by dt, then it would be reversible. But it is a finite means delta T. General name of finite is delta T different. So that finite driving force works. T system plus delta T. Keep it here. Then you see. Now you please tell me. Okay. Then he said now look finish this thing. So this is okay. Hence DS system plus what is DS universe actually? DS system plus DS surrounding is what? Right quickly. DS system copy where it is. DQ reversible by T system. Right nicely. DQ reversible by T system and minus DQ reversible by T surrounding. Oh, what is that? Last line is where? T system plus delta T. Will you please answer this term? This expression is what value? Numerator same. This is delta and 0.
Because that system plus delta is greater than this system.
No, this value is T, 0. Greater than 0, that's right. Because this is greater, denominator greater, so this value is less, so negative less, positive greater, means positive. Positive is right, positive. You 100% right is positive, and you are all set. Greater than 0 is lucky. Greater than 0 means positive. Okay, obviously this. Okay, very good, very good. So proved. So again, so second law established. So the second law is once more verified. Move on. Last one. Last one is adiabatic. Anytime you are coming across adiabatic means what I asked you, be on your guard. Be careful. Adiabatic, dangerous thing. Just take up the dangerous thing. You should be able to answer some difficulties, okay, and solve the, remove all this, remove all. This is over. So case, remove this, huh? Remove. Can I remove off? Okay, bas, insulate. So next is adiabatic case 3. Example 3 though. Example 3. See, adiabatic process with n moles of ideal gas. So adiabatic process with n moles of ideal gas of an ideal gas. As before, these are all well known. So you have no difficulty about the system. What I'm talking about, process and system. No, sir. System is a process. But still, I'm sketching this first of all reversible, since I'll consider reversible. Please quickly. This is your, you recall PV to the power gamma, etc. commonly. So this is your reversible adiabatic. Reversible adiabatic. You know the equation PV to the power gamma is constant. I am not writing all these things. Reversible adiabatic. One, maybe 1A2, not bad. 1A2. Right. Start. Start. First case is reversible. Second case is irreversible. And establishment of this. First case, reversible adiabatic. And expansion is the right expansion. We are more defining this path expansion because I am considering expansion. What is the path? Is path 1A2. Happy? Start. Dear system. Let us see. Let us see one by one. What shall I write? Let me write as I know, as we know. This is our stack here. What you write? Follow this. dq reversible by T. dq reversible by T system. T means T system. Is what, sir? What? How much heat is in a reversible? Since reversible don't have any direct. Reversible path, I am considering equation is also, relation is also on the reversible. So no conflict, no nothing, confusion. What is the dq reversible in adiabatic? 0, sir. No heat is. That is the adiabatic, sir. No heat is exchange. So 0 by T system is 0. Right, this nicely. Here surrounding likewise minus dq process by T surrounding. Since you don't have to minus dq processes, minus dq reversible, that same, right? Reversible, right? You don't care, reversible, irreversible. By definition, adiabatic means no heat actually is, surrounding is off actually. As far as heat transfer is concerned, surrounding is off, no role. But as far as mechanical work interaction is concerned, that is there. Cylinder piston. That is very much working. Okay? Adiabatic work done by the adiabatic process. Area of the curve, etc. You know this. No heat, sir. No heat, sir. So this is likewise 0, 0. Happy? Good boy. Over. So DS system plus hand. Here is the first line. DS system plus DS surrounding is 0. Over. Second case. Second case is what? Gas irreversible. Adiabatic and expansion, obviously. Path I am showing. Path. Irreversible, no? Very well. Many irreversible possible. Many different. So I am considering one of them. Can I? With double arrow maybe? Double arrow. So this is called B. So I shall write irreversible. What's the name? 1, B, 2. 1, B, 2. Shall I proceed? May I proceed to everyone? Your name is? Huh? Sancho? Saira? Your Taira. Your name? Sanjana. Right. DS system is what? Tell me. DS system, you know, you do this. What I advised you? For irreversible, copy paste. Yeah, I say. Because I link up with the reversible, I don't know anything else. Because it is due to reversible by T. Okay? You can write. Because irreversible or irreversible, you have to write. This, if there is any complexity, that is here. Irreversible path, but you have to write. For system, you have to write this. Okay? Since it is entropy is a state property, as I told you, see, it does not matter which path. So reversible value is okay, here 0, so I write 0. And DS surrounding the minus dq process by T surrounding. What is the process? Minus dq irreversible path by T surrounding. And you know, adiabatic means surrounding, no surrounding, sir. No heat transfer from surrounding. So it must be 0, sir. No one can stop it. So 0. So DS universe is what? 0 plus 0, 0. Second law is violated. A great achievement today in this class. That second law is violated. Second law fails today. In this classroom, second law fails. It's a great achievement. But that can be. Where I made a mistake? Anyone guess? Where I made a mistake? Yes. That's right. See how deep interconnection. If it were so blindly, see how we said, in fact, said this should be extended there. Now see how verified by the second law also. It is not here. I didn't let it on. I was checking whether you follow. You can you can comment or say you can debate, doubt. So this is not adiabatic process. Path affects the state, final state. Path affects the final state. If the reversible final state is here, irreversible can't be here. That will be, we know the answer, 2 prime. And so change all everywhere. I didn't get right here. Now I write, okay, 2 prime. Okay. So sir, how can you compare? This is 0 when initial same, final same. Initial same, no doubt. Final is one case here, in another case there. So no comparison. So it cannot be 0. Now, in fact, we will see now that it will be positive. Let us see what we will get. So this is utterly wrong. I repeat this. This part is okay. DS surrounding is fantastic. In fact, this is your problem. Yesterday's class test problem. This was the B2 that I asked you to find. What is this volume? Okay, that's a different issue though. But this, okay, just fresh. So what is the? I start right. So what I will get this, sir? In this case, sir, this. So right, and this DS system you can write, right? But I tell you what, you do one thing. I follow. Tell you 1 to 2 prime though. You anyhow connect 1 and 2 prime by reversible connections, reversible paths only. Because then you get DS is anyhow state property too. State property here to here, say anyhow. Get correctly DS. And then apply. Anyhow means it can be here. This is this constant pressure, constant volume. It can be one isothermal, constant volume. Like these are numerous. Anyhow, any reversible. So easy reversible connection is here. Is it shown here? So I consider this is a constant pressure, constant volume. So 1 to B and B to 2 prime. Okay. Then it leads to 1 to 2 prime. So I am writing DS system what to what? 1 to not 1 to 2, 1 to 2 prime. Here you say What is ds system? 1 to 1 to 2 and 1 to 2 prime. How they can be same, sir? Entropy does not mean state property does not mean it will be always same. The condition must be maintained. Initial state and states same. Then you compare, sir. Anyhow, so I'm doing this for you. For if I may write, I'm doing as if now. Okay. This is my reversible. This is my reversible. I consider. I'll get ds. Same result in the dotted also. Because 1 to 2 prime. So ds system 1 to 2 prime is broken into two. 1 to, tell me, b plus ds, or rather, sorry, you don't have to, okay, follow this, it is better you don't do this. What you do is okay, it's possible also. But I'm changing my mind, okay. Why you are taking this, unnecessary involving this? You have to reach here to have any of the reversible connection. One is already here, sir. 1A2 is already there, and here to here. So it is better. Shall I remove this? Return it to the previous consideration. I'm explaining you. Don't worry. It was no. I'm not cancelling this. But I'll reach there. My job. Okay, 1 to 2 prime. What shall I get? Sir, 1A2, the reversible adiabatic. Anyhow, how many? Always when means how many is countless means infinite. How to get one point to another point? How many connections possible? 1 to 2? How many? Infinite. These. Oh, sorry. These. Go outside. Come back. Heat. Infinite. So this is actually your 1 to 2 connections. Anyhow, but good. Now this time you may consider reversible connection. Baba, reversible is very easy. So 1 to 2. Shall I write? 1 to 1A2. 1A2 means 1 to 2 actually. 1A2 plus, tell me, 2 to 2. So 1 to 2 prime. Final 1 to 2 prime. 2 to 2 prime. You have this yellow. The reversible. This is reversible. So what quickly? It's not so important. What is ds1 to 1A2? How much? ds1A2? Reversible. 1 to 2. 1A2 is reversible adiabatic. 0 plus. This is plus. 2 to, see, it is not 0. Something is actually, say, sticking out. 0, I thought 0. No, plus. 2 to 2 prime. So what is this? This is a constant pressure process. You know NCP, constant pressure, you can write the constant. So NCP, reversible by NCP dt by T. Constant pressure. NCP dt by T. Okay, this is a constant. 2 to 2 prime is a constant pressure. Reversible you can consider. So NCP dt by T. T is what? NCP dt by T. Okay. So this is actually T system. Actually, NCP dt by T system. What is this anyway? This is, tell me. NCP dt by T. Guess. dt by T means positive or negative. We are not finding out the values. We have to integrate them, etc. Or positive. dt is positive. NCP T. Okay. dt positive. dt temperature rises or falls. Rises. Volume is greater. Pressure same. Comparing 2 and 2 prime. Pressure same. Volume rise greater temperature. Okay. So this is actually so positive. Right here, since right here T2 prime is greater than T2. This you know, right? V2 prime is greater than V2. Right also. I don't have space here, but I should have. And V2 prime right here. V2 prime greater than V2. Is apparent from figure V2 prime is greater than. Okay, happy. So you see today at least we have believed the downfall of the second law of thermodynamics actually was about to occur here, but somehow we have actually saved the second law of thermodynamics face, also our faces also. So what is this? DS universe? Here. Or what? We attend class. What time it is now? What time it is? Get in. DS universe is what? DS system plus DS surrounding. Quickly. How much? Tell me. Tell me. Positive quantity. This system is positive, to happy to. Plus, this surrounding. Somo Babu, this surrounding. Okay. So they have already written. It is already covered. You see, this is DS surrounding 0, and this is actually something there was doubt, so it is positive. Positive plus 0 is what? Positive plus 0 is positive. Happy? So you all said. So again, so still once more. So again, the second law is verified to be correct. We cannot go beyond this, okay? But it is true for any process. So we can see this way. Remove all these things. Over. Next topic is what? Next topic. Can I remove this? You all set? Remove this. Remove this. All clear. Next topic. Continue. Second law. The remaining syllabus is the second law of thermodynamics. Okay. These things actually, studies made on the second law of thermodynamics. Many different aspects. Next topic is what? Follow this. What I am trying to say in some interesting thing. Okay. So, what happens? This is a question. When a reversible process is reversed, and an irreversible process is reversed. Irreversible process is reversed. Just follow this. This I discussed. Didn't I discuss this? When a reversible process I was discussing, I said it is not that irreversible process cannot be reversed. Why it is named so? Why reversible process is named so? It can be reversed. I said both system and surrounding will return to the original state. Completely, total reversal. But in surrounding also, reversible process also, it can be, system can be reversed. It is not. But that will affect surrounding. Permanent change elsewhere, means in the surrounding. Today we will see verification. That was about entropy. Since that was actually, we could not consider entropy that time. So today is the time. Quickly, follow. Reversible case 1. Reversible cycle. Quickly help me, since this is very interesting and easy. Isothermal process. Reversible cycle with isothermal paths. N moles of ideal gas. It's always, who start? I'm sketching this side, I'm writing that side. Sketching, first of all. You follow with me quickly. It will not take so time if you are smart, okay? But you can be easily. I'm doing something. Reversible isothermal. Forward. No problem, sir. Very good. One, A2, sir. Forward. Reversible quickly. So, forward path. I will reverse it, sir. Forward and backward. Reverse it. Forward path is what? Reversible path. Since reversible cycle, then I will consider irreversible cycle also. I will reverse the irreversible path. Forward. Irreversible. Later. Second case. Reversible path, sir. What is this? Forward path. One name. Give the name 1, A2. Quickly tell me. DS system. Right? DS system, as you know, quickly write this, then I will get integrated value. dq reversible by T system is what? dq reversible, I told you a moment ago, what is this? Isothermal process, dw reversible by internal energy is out. Shall I write once more for you? du plus dw reversible by T system. What is du, sir? Isothermal is pdv by, right? Keep on writing. pdv by T. PdV by T. Achha, T system or T pdv by T. You have to write this. P by T is what? As I told you, nr by V dV, P by T, PV is nRT, right somewhere, PV is nRT, keep it handy. P by T is nR, oh, nR, P by T is nR by V, I have written that integration, I am giving you entry, yes, R, sorry, okay, follow me. Achha, this limit, achha, or say alternatively, this I will do. Achha, this one, what is this? Achha, this I will not do. I will not do this part. It is, achha, right. Write this. This is the PD by T. Achha, alternatively I am writing. If you integrate this, can you tell me? Here, I'll show you. Integrate this. Achha, first of all, I do. What is the delta S system? Quickly. Integration ds. 1 to 2. What is this? Tell me. nR dB by V. Integration 1 to 2. What is the answer at least? You know. nR ln V2 by V1. Remember. Very easy. If n is 1, R ln V2 by V1. This is the entropy change. This is a new value. Delta H you know. Delta U know. Delta is another entropy. Okay, this is. But I'll work this side for you. Okay. What is the same result I am coming? Alternatively. Alternative that may help you quickly. Alternatively, what is this? Delta system. Delta system is what? Tell me. Integration dW. Here, I am picking up from here. dW reversible by T system. Happy? 1 to 2. This I am picking up. Rather than this, I am picking up this dW by T system integration. T system is T actually. T system, I'll make it T. Is what? T system is isothermal. T is outside. That is T, right here T. So it is by T, and the integration of dW reversible is what? W reversible. Between 1 to 2. 1 to 2. What is that value? Recall. W reversible is what? nRT ln V2 by V1. Remember? Good boy. So nRT, write that. Right? You can see this is returning to this value. Happy though? Returning to that value. So you are same reconcile. So is nR ln V2 by V1. But I will pick up this one for comparison purpose. W reversible by T. Okay, again. Say I am writing W reversible by T. Suppose this amount of work, reversible work, is 40 joule. For example, I have to take is 40 joule. Say, you know very well what is that? 40 joule. 40 joule. Why this? What is that means? Work done in the reversible path. You know what is that? Area under the curve. PDB integration, all such things. This value is what? nRT ln this much is what? This much is what? 40 joule. I have say 40 joule. Say. Okay. Say. Happy to? 40 joule by T. What is this? Can you show me? What this 40 joule is what? Area. Area handily, not bad. 40 joule. And express, this is a graphical expression. Who will measure area under the curve? How you do this? What is the answer? Easy. Sir, what are you doing, sir? nRT ln V2 by V1. Sir, n is V2 by V1. Sir, whatever area, who will measure area? Sir, graph paper, long enough paper. Sir, long enough store, we have to go. Graphically also. Means graphical for presentation is good. Expression, this is it. Figure is actually very catchy. Helpful. 40 joule by T. Okay, very good. Quickly, what is delta system? Delta surrounding. Quickly, delta surrounding. This side. Tell me what is. Tell me minus. Okay, ds surrounding is what? Okay, ds surrounding. Start ds surrounding. What? Minus dq. Tell me process. Process. Then I write process by T surrounding. You write cancel T. Process is reversible. Surrounding is T. Surrounding is the T system isothermal. T system is also T. Then what is then delta surrounding? Please. Then this leads to delta surrounding. Can you tell me? The same dq reversible is the same actually W. Shall I just proceed this? dq reversible, okay, is what? Minus delta should be q reversible, okay? Q reversible means W reversible. Shall I show it how actually? Right this. This is W irreversible. You have written somewhere. dW reversible is PDB. What I have written here? nR by V. Alternative followed W reversible. So it will be dq reversible is also right here. Write here dw. Can I write this? Write this. This is also dw reversible. Process is reversible. It is what? The indication is w reversible by t. Okay. Okay. dw. Okay. Easy. Very easy. Same actually. Same opposite sign. What is the dw reversible? I have already considered 40. So it is minus 40 by t. What is the unit by the way? Unit?
Joules per Kelvin.
Joule per Kelvin. Okay, you follow this. And difficulties, follow. ds surrounding is negative of this. Negative. Exactly are negative. Whatever here, negative. Why? dq process has been dq reversible. T surrounding has been T system. Which is T? Which is isothermal, exactly same. So minus 40 by T, no surprise. So plus 40 by T, minus 40 by 2. Makes sense also. This is, keep it handy. Now, so can I remove this? Can I remove this? Actually, I will let me write. So what we get? Forward path. So right here. Forward 1 A2, right. Delta system, right. Tell me 40 by T. And delta surrounding, tell me minus this part. This discussion is there. Somebody, so remove this. Now remove this. Happy. You can check here. It is sum to 0. Okay, but don't worry. This is not our main aim today. Okay, this. So now backward. Next case reversal of 1A2. That is the backward path. Quickly and very quickly. Backward path is what? 2. What is that? 2A1. Happy? I'm just quickly. 2A1. What is the delta system? Now tell me without. Can anyone very easily? Delta system? 1A2. You know. 2A1. 1A2. What does it mean? 1 to 2. What is 1A2? 1A2 though. 1A2 though. What does it mean? Yes, S2 minus S1, sir. Break it. The individual values until it is not further divisible. Do it. Then come back wherever you convenient, comfortable. Delta S2 minus S1. The entropy of this state minus entropy of that. Nothing like that. Easiest. So, can I write? What is this, by the way? Tell me. It is, sir, 1A2. That is, can I write somewhere here? Okay. Achha, this is S2 minus S2 of system minus S1 of system. Good boy. So, what is the reversible? 2A1 is what? S1 minus S2. S1 minus the negative of that. So, good boy. So, let us write. What is the path? 2A1 is nothing but S1 minus S2. If you write this, it is minus 40 by 2. Happy? Any problem? Minus 40 by 2. What is the unit? Minus 40 by T. I have not given the units. I have written minus 40 by T. Is what? Joule per Kelvin. Entropy unit. Okay. So Joule per Kelvin. Okay. So minus 40 by T. See, plus 40 by T. Minus. Reversing. S2 minus S1. S1 minus S2. So everyone knows, sir. And delta surrounding was always, that was discussed, opposite, reversible. Exactly opposite. So this time it will be plus 40. This is minus, means reversal is what? Compression. Heat is rejected to the surrounding. The surrounding gains heat and system loses. That's the entropy negative. The heat is negative here because it is system rejects. Compression, system rejects. So negative, loss in entropy and gain in entropy for which gentleman? Surrounding. Obviously the same 40 by T. Again that, okay, the same logic, the opposite of this, okay, because one is negative minus 40 by T. You may write this minus 40 by T is plus 40 by T. Now this is a time to establish something. So over the cycle, tell me delta system. What is the cycle? Tell me. What is the cycle? Right. 1 A forward, backward. That's it. This is the cycle. Okay? Reversible cycle. over the reversible cycle, right? Reversible, underline reversible. Delta system is what? Total. I'm not getting delta universe, that is positive, that is already established. Delta system or cycle forward how much? 40 by T minus 40 by T. So right, delta system forward is 1A2, you can write, plus delta system backward means reversal. What is 2A1 is 40 by T minus 40 by T is how much it is? 0. As it should be, sir. Cyclic process and entropy state property. It comes back where it was. Change is how much? It comes back where? What is the entropy change? No change, sir. It is return to the original state. So S1 minus, I'm starting from here. S1 minus going here, returning. Then is not continue, is still continuing and returning here. What is the entropy change for this? 0. Same point, sir. So 0, as it should be seen, it constitutes a cycle. Delta surrounding what you are interested here. This is about system. Typically we consider system. Surrounding is what? Take up this again, forward. Delta surrounding forward plus delta surrounding reverse backward. Now, corresponding delta system, path is executed by the system and corresponding delta is. What is this value? Forward is how much? What is your, say, forward minus 40 by T plus 40 by T is how much? Oh, surrounding also. System returns to the original state. Surrounding also return to the original state, means exactly reversed. How must be? This is the reversible process characteristics, that it can be totally reversed. Both system wise, surrounding. System returns to the original state, surrounding initial state, and surrounding also return to the initial state. No change in the state. Okay, 1 to 1. If it was somewhere 1 prime here, change of state. But since same no change, surrounding is also returned. So it means, so we can conclude, which you have already concluded, or which you have already learned. So we conclude, when a reversible process, when a reversible path, when the reversible path is reversed, very quickly, is reversed, both system and surrounding return to the initial state, to their initial states. Hence the name reversible. Exactly reversible. Reverse, you can reverse. Very good. Remove. Can you remove this? Now quickly take up the more challenging one. What is that? Irreversible. Have I sketched this? I have not sketched it. So next case, irreversible. Do the same thing and see how it is. Then you have a good concept. Okay, good comment about this second law statement. This is actually second law statement I am writing. Okay. Next is next case, irreversible cycle. What is it? Forward and backward. I'm sketching this. So it is better I sketch with this. So better, since already faint lines are drawn. This is the forward, as you know very well. You know, recall. No problem, sir. 1B2 na? 1B2. Okay, you can give a double arrow. I'm not giving arrow. 1B2 is the forward irreversible. What is the reversal of this? Reverse any number, anything above. So yeah, give an arrow. Arrow is necessary. This way, right. Not only here, not give here also. So this is the forward expansion, irreversible expansion, and compression. Tell me, you recall. So I will not waste time. Recall. There are many. One I am considering is this, and then this. So you give arrow here, returning through compression and compression. What is this? 1B2, 2C1, 2C1. Follow. Right? Right here, irreversible forward. It is better, right? Right here. This is right here. Irreversible forward path, and you write this one, irreversible backward path. Acha, don't worry. Shall I remove this? This is not necessary, na? This is already over for the reversible one, eh? All remove. Unnecessary. See, irreversible backward path. Consider reversible cycle. Irreversible. Consider this irreversible cycle. What is this? Okay, I can give you 1B2. Given name 2C1 back. Okay, quickly forward. Delta S forward quickly. Delta S system. Again follow. Isothermal delta system. I'm taking back directly delta system. And DS integration same is what. I am sorry that I removed this, but you remember you have noted down delta system. I ask you forward, simply, not backward. Later. Forward has two segments: system, surrounding. Then backward, system, surrounding. These together makes an irreversible, and reversible also similarly, which have already completed. So system, surrounding. There are two cases I am considering. Two aspects we are considering. Okay, so delta is system and surrounding both are considered. So delta system, can anyone? 1B2. So what is the forward? So forward. Delta system forward. Please tell me what is this? 1B2. Right? Tell me. Answers are with you. What will say? Sir, I will not take up, sir. I will not go about it. Because the definition requires reversible connection. Systems are DQ reversible means Q reversible. So it is linked up with the reversible one. I have to. So I have already answered. So same answer here as here. Because 1 to 2, whichever, who cares? Reversible is the same result. Entropy is a state property, same initial, same final. What is that value? 40 by T. Happy? Because, that is, so sir, copy paste. You are expert in which? Copy paste, okay, copy this value. This is, you can write, you could try, but this Q irreversible will not work in the definition. Definition is what? DQ irreversible. Or DQ reversible. What is the system? System is what? DQ reversible. So reversible, you have to connect with the reversible. Remove from your mind this one. For system, remove. I tell you, first you remove this. But question is about this. So strange, sir. Very good, sir. You are asking to remove what is asked. Go to the reversible connection. Ask some reversible. Because some reversible connection result. Not only this, if I give this one new path, I give you this, well, I have this copies. Verily, entropy is a state property. So, it is same as 40 by delta system is reversible forward. What is that? Writing for you 1A2. Is what? This is actually S2 minus S1. What is that? Tell me. I am writing all possible things. Okay. Is what? 40 by. Have you though? You must be very happy. Okay. Then delta surrounding. What is delta surrounding? Delta surrounding. Right, you have to write. DS surrounding, start delta surrounding, like DS surrounding. I am writing for you since it is actually little bit critical. Minus DQ process. What is now? This will make some D surrounding. Okay, tell me, keep on. Minus, tell me, DQ process is irreversible. Is by T surrounding is the system. T system, why? Can anyone quickly? T system are written. T surrounding are written T system. No doubt. Why? Because isothermal, sir. Isothermal, thermostated, same temperature. So this is what? Minus. So what is this? Or integration. So this leads to integration, or this leads to integration. Delta surrounding is what? Tell me. Integrate. Minus DQ irreversible by T system means T. Minus T system means T. And you know, T is a cost outside. Integration is what? Minus Q reversible. Irreversible. I am very sorry. By T. And what is that? You know very well. Number. Q reversible in the form of what? In the form of work done. User. What is in the form of work done? Q irreversible by T. I have reached up to this point. What is that? In the form. And W reversible by. Same as W reversible because internal energy change is zero first law. Every moment first law is to get internal energy change is zero, sir. Isothermal process. Okay, so. Oh, so very alert. So W minus W irreversible by T. Please, I will be very happy. See the figure and tell me a value. So W, you know irreversible work done means area under the curve. If it was 40 by T, it will be expression I don't want. It was 40 by T, it will be less than 40. So this area under the curve is this much. 30, you know this. Area under the curve, you know very well. 30. So let it be 30, say. 30. Say, noting here, noting. W reversible is always greater than W irreversible. This is your knowledge. 40 by 2 is greater than 30. 40 greater than 30. Yes. Okay. 40 joule. 40 joule. 40 greater than 30, I understand. Don't. Anyway. Okay. Over delta. So first part is over. Can I jot down this? I'm writing here. Huh? So summarizing, then I'll remove this page. Summarizing. Forward path. Forward irreversible path. Forward irreversible path. One. Oh, what is this? Forward irreversible path. What is the name? Tell me. 1B. Tell me. So don't worry. 1B2. Two segments are right. Copy delta system. Just you're saving here. Save here. So that I will remove that side. Delta system. What answer? Write nicely. 40 by T. 40. Oh, sorry. I have not completed this. I am very sorry. What is this? Minus 30 by T. Remember? Huh? Minus is there. Minus 30. Delta surrounding is what? This is 30. This is less than that. But minus is here. Huh? So minus 30 by T. So again, entropy is gained by the system. System increases. The forward path system has gained entropy. He got heat, Isothermal process, and entropy has increased, by 40 by T, and surrounding likewise lost entropy by minus 30 by T. So in terms of change, delta system, delta. One segment is and remaining only one, the irreversible. Then forward and backward will combine at the end and make a similar statement. So hence we conclude that I'm removing all these things. Okay, this side I'm removing. Since already I have noted this. What happens? The question, main question is there. Remove. Now quickly take up. Backward path. Backward irreversible path. What is the name? Name will be helpful. 2C1. Quickly again. You should read prompt. You answer quickly. I am skipping actual step. Delta system again. You know fuller what shall I do? Delta system, delta surrounding. Delta system. I will be very, very happy to the power infinity. Okay. It will answer 2C1. Answer. Okay. No hanky panky. Minus.
I can say this one.
Correct answer. See why? Forward is 40 by T. The backward would be what? Forward is 40 by T though. This way or this way does not matter. System. Straightforward. So this is actually reverse. Means if it was S2 minus S1, it is now like that. Good, very good. Yeah, you are following this. Very interesting. See, end to end. C don't care. Look away from C. Fast, fast. Then this O, B, C, D, who cares? G, H, I, J, K, L, M, N, O, P, Q. 1 to Q matters. Difference. So S1 minus S2 is what? It is correctly said. S1. It is negative of the minus. This was S2 minus S1. Can I write here for you? S2 minus. If it helps you, who knows? S1 minus S2 minus. Happy? Last, very delta surrounding. Again, same way is what? Let me write this minus. Okay, again, ds surrounding is what? Quickly minus dq process quickly. I have to actually see. I'll remove all this. I'm doing over t surrounding. See, in isothermal dq process is dq irreversible quickly by t system. Means t system because isothermal. Right here somewhere. Since isothermal process, since in an isothermal process T system is T surrounding. Exactly. No dt. Isothermal dt is where? dt, dp there on the mechanical side. Don't do it. So it is is minus dq. Achha, right here. So this is nothing but t. Okay. Integrate. Delta surrounding is what? Right? Minus dq. Right here. This is better. Delta surrounding is what? Minus dq irreversible by t is what? T is outside, constant 1 to 2 actually. So it is 1 to, okay, 2 to 1 rather. Okay, don't worry, is what? Tell me, q irreversible, integration q irreversible by t is outside, integration t. It is nothing but w irreversible, na? First law. Delta plus w. Why I am going to w? Because w is well known. We know q mostly from w and the first law. But directly sometimes known CPDT, constant pressure, directly, heat, dq. But anyway, minus delta U plus W irreversible. This is 0 by T. What is the W? Give me a value. See, for the path I have given your delta surrounding 2C1. What is the W irreversible? What is the work done? It is now numerically. Numerically is what? Greater than 40. It will area under the curve will be this much. 50. But tell me, what is the W irreversible value? Tell me. 50. What is the work done? 50 or minus 50? 50 I can write. Shall I write? Only. So minus is minus. Okay. This is 50. Why? Area under the curve. By temperature. Work area under. Compression. Forward expansion work done by the system positive. 3 things. First day, second day I don't remember. Expansion work done by the system and positive. Again, compression work done on the system negative. Mathematically see. So this is also people write this at volume final volume. So it will be negative. So it is how much? It is minus. So right minus nicely minus 50 by T say. Okay, numerically is okay. See, work done is match. So what is delta S total? Quick over. So minus 50 by plus. Please write plus 50 by T. Happy to. So quickly sum up. Delta S system cycle is what? Forward or backward? Delta S system forward. Hey, how?
12:35.
No, 25. 5 minutes. 5 minutes. Alert me. Go slow. Only say your last point. Very important. Delta S system cycle is what? Delta S forward. Delta system cycle is what? Delta S forward, system forward plus delta system backward path. These are answered for you. What is the forward? I can write once more. What is the forward path? 1V2. What is the backward path? 2C1. What are the values? Already we have collected here. Backward is okay. This is about surrounding 40 by 2 forward and here minus 40 by 2. So shall I write this? 40 by 2 system. Jotting down on system. 40 by T minus 40 by T. What is this? So what is the change in the entropy of system? Nothing, sir. Because it has returned to the, see, Start, forward, back to 1. No, sir, it makes sense. So one cycle. What is the cycle name of the cycle? Tell me. 1B2 C1. Already I have written somewhere. Top. I forgotten. I wrote. So 1 to 1 cycle, as it should be. And last thing is the delta surrounding cycle. Shall I write here? Again, here. I am removing this line only. Delta S surrounding cycle. Right again, delta surrounding forward plus delta surrounding backward. What is the forward path? Copy here. Sir, minus 30 by T. See, forward, all about forward here, system surrounding. Minus 30 by T. This minus 30 by T plus, what is the backward, sir? 50 by 2. Good, very good. Plus 50 by 2. What is your comment on this? Minus 30 plus 50 is what? Must be 20 by T means plus 20 plus highlight plus means positive, sir. What does it mean? Surrounding has not come back to the original state. To its original state. Its original state. Surrounding is the remaining part of the universe. So no comparison with the system. Surrounding has a state. Although immediate surrounding work actually, the whole surrounding USA or say North Korea, they don't actually interact here. Immediate surrounding is the actual part of the surrounding, is the surrounding. Obviously interactive, okay, in the interactive, okay, closeness is there. You should able to interact. So whatever, what's the surrounding? So what is the, it has permanent change in the surrounding. So that means surrounding has not returned to that is the surrounding, writing once more that the surrounding has not returned to the original state, to its initial state. That is, there is a change. Okay. That is, there is a change in. That is, there is a permanent change in the. But I write once more. Permanent change in the surrounding. Write it nicely. Permanent change in the surrounding. So once more you write. To finalize over what happens. Question. For reversible cycle I have written, system returns to original state, surrounding returns, but I am writing. So in case of irreversible process or say spontaneous process, remove this. So right, this I am writing as if. So we can conclude I'll ask a question, simple question, which you have already read, but you answer this. So we can conclude in an irreversible process. When an irreversible process is reversed, and the system is made to return to the initial state. I am reversing means what? You reversing by what? I am returning the system, and the system is made to return. Remove all this. Over is made to return to its initial state. That is the reversal. And reversing means what? So you are saying reversing, then how we are returning? No, system returns to its initial state. The surrounding does not return. Surroundings does not return to its initial state. Surroundings initial. To its initial state, implying there is a permanent change in the surrounding. There is a permanent change in the in the surrounding. Permanent change means permanent change in the state of the surrounding. Permanent change in the means permanent change in the states. We go by state. State is what? Entropy, sir. Surrounding entropy has not returned to initial value, so there is a permanent delta S. What is positive? Positive means different entropy. Surrounding start entropy and final entropy are different. So permanent change. This is the message of the surrounding. So this actually also this is so. Hence the name you write. Hence the name irreversible. Why reverse? You cannot reverse fully. System can be, but as it at the expense of surrounding. A reversible? No, you can do fully. So system return, surrounding return, exactly, totally. Hence the name reversible. Hence the name reversible. But giving this, I am writing this something. Achha, let me write. I forget. Hence the name irreversible. Okay, this is second law statement. This is actually the second law statement. The already one is for the reversible road, not that you write is a second law statement. So we can conclude with a reversible path when the system is returned to the initial state, the surrounding is also returned to the, so that is the statement. Second law statement. This is also second law. A second law statement. There are many statements coming. Okay, these are already second law. Universal second law statement. I will ask you. Write this first. I will ask you one thing. So this is how we are distinguishing reversible from irreversible. Okay, very good, very good, very good, and very good. Okay, that surrounding will be permanent change. But how I instructed you to know that it is reversible? Which way you will distinguish? That it is surrounding, it is reversible and it is irreversible. Which way? And permanent change, then you have to calculate and see many things. Okay, or what is the how will represent that? Okay, that it is reversible, it is irreversible. Easy way. I say number of ways, reversible and irreversible. I say number of ways. It is finite driving force, infinitesimally driving force. This I said. Original definition of reversible and irreversible. What the other things that I said? Okay, this is actually the permanent change. There is a permanent. Hence the name irreversible. And also I said, after all this I said, but this is the easiest way. One is definition, finite driving, infinitesimally small driving force for reversible process and finite driving force for irreversible process, one. Second, what I said, the system, what is the meaning of this reversible? It can be reversed in full, both system and surrounding. But irreversible does not mean the system cannot be reversed. Yes, it can be reversed, but at the expense of the surrounding means by causing a permanent change in the surroundings. This we said. But still I said, okay, but don't, this is the easiest. Perfect backtrack in the diagram. Perfect backtrack. No backtrack. Forward. No. No. This is not irreversible backward. Remember all, grip all these things. Okay, this is actually what is outcome of this permanent change. So for this, this side work done and that side work done is not same. Work done by system and work done on system is not same. It is 30 by T, it is 50 by T. No, quantitatively. So there is a residual entropy change. Happy? So with this topic has been exhausted. This is actually I wanted to this. So remove this. Next is quickly. This I will initiate only, but you will let me know 5 minutes before. And I'll stop whenever it is. Okay, but just initiate this. Okay. Efficiency. Okay. Efficiency of a cyclic engine. Many of you have missed this class. First class I consider 2 cycles. One is on the basis of adiabatic isothermal, another is on the basis of constant pressure, constant volume, from which we finally get all these things. ds is reversible by writing the area. These things we have proved. Okay, first class. Missed many of you. Efficiency of a cyclic engine. Not bad. So I am sketching one cyclic engine. You see, following the commonest which is also known as Carnot cycle, but normally we consider isothermal adiabatic cycle, which is Carnot cycle, though actually this crudely represents our steam engine cycle. Crudely, okay? At least thermostat 1, 2, 3, 4. Happy and very happy and very happy and very happy. I said this. This is actually P1, V1. I should not mention so many things. Right. N moles of ideal gas P1, V1, T1. This is P2, V2, T1. This is P3, V3, T2. This I discussed last class. P4, V4, T1. You may know this. Okay. But this is T1 isotherm. T1, okay, thermostat. T1 isotherm. T1 temperature T1 isotherm. Before? No, oh, this is T2. Thank you so much. Yes. This is adiabatic, right? Isotherm. Isotherm. This is T2. T2 isotherm. Note few things. T1 is greater than T2. This is called source temperature. Source temperature, which is boiler, steam engine boiler, 500 degrees centigrade, say, okay, sorry, 500, 300 degree, 273, 27 degrees centigrade. Superheated steam, T1. And T2 is the ambient temperature, room temperature. It is called sink temperature. Source and sink, important terminologies, and this cycle is often known as Carnot cycle. This is isotherm, this is adiabatic. So isothermal, adiabatic, isothermal, this is also adiabatic. This is expansion, compression. Isothermal expansion, adiabatic expansion. Alternately, isothermal compression, adiabatic compression. These I discussed in details actually, a lot of time, adiabatic. Reversible, all reversible steps, okay? These are things, all reversible steps, okay? What I say, just I'll begin. Efficiency of a cyclic engine. Or cycle. Efficiency of a cyclic engine is efficiency. What is this? Common sense. Anything you say, common is what? I'm writing. Work done by the cycle, means by the cyclic engine, by the cycle, or done by the cycle, by the, all done by the cycle, the system and cyclic process, in the cycle, okay, done by the, work done by the system over the cycle. Someone is talking to us. You are doing what? Why sitting so close? Separate. Yeah, separate looks bad. Okay, concentrate here. Okay, I will help you more than her. Okay, or you will help her more. Okay, or more than me. Okay, I will instruct you. Okay. So work done by the system over the cycle, and this work, how much? Follow. A heat admitted to the system at high temperature, at the source at high temperature, that is source temperature. Source, a technical name, source and sink. Okay, now follow. Why? This is the logical definition. Why? It is said heat is absorbed by the system, means from the boiler. System is what? N moles of ideal gas, say. Means it is steam. Steam is the system in the steam engine. Okay, so it is actually that is actually now worked upon. So heat is given by the boiler to the system. Cylinder piston arrangement, cylinder crankshaft you have seen, cylinder piston and crankshaft, and he hooked up with a wheel. So it is moving back and forth, and that is rotated, taking actual rotational motion on the plane of the wheel, and it actually makes cycles and the locomotive moves on. Okay, horizontally. Okay, these are the things. Okay, boiler, source temperature. Sink is the ambient temperature. Acha, boil sink temperature, ambient right here. Sink temperature, source temperature is ambient. Ambient temperature, room temperature. Happy? So what is this here? Please I write it. What is said? Definition. Logical definition is you are given so much heat. Let us see how much you convert into work. This is the question. You are given, if possible, completely convert. Then you are 100 efficient. The work running 100% efficiency. This is the logic. You are given your input. Whom is system is input from the boiler as so much heat. Thermostat. Boiler is a thermostat running 500 Kelvin. And this is running room temperature 300 Kelvin. So you giving us convert, then it says, okay, perhaps I will not be able to fully convert. You cannot, because you know some of the heat I will lose through the compression. I reject to the surrounding. You know, system is giving and during the compressions, system is reject compression, you know, work done by the system on the system means heat is rejected to the surrounding. So some of the heat if I reject, how can I ever completely convert into work over the cycle? See, this is the message. Okay, I'm writing this mathematically. So write work cycle, double cycle. And heat admitted to the system, what is that? Tell me, what is this heat? Okay, you write here, I write here. Q1 corresponding value is Q1 and corresponding value is Q2 isothermal process. NRTLA, N moles of ideal gas you may consider. N moles system, N moles of ideal gas. I discussed this. System, N moles, ideal gas for simplicity. For happy. So, W cycle over the cycle, okay, for how much heat? Q1, what is the answer? Tell me, how much heat is given? Where? Who gives? This is the isotherm high temperature. T1 is source temperature, boiler. Give heat. What is that value? You know that value. But you answer me. But I'm writing. This is the precisely this heat given in this isothermal process. A moment we are saying the 40 joule, 30 joule, okay, process. Given denominator, of which W cycle. Let us see W cycle is what? Will you accept that W cycle is what? Q cycle? You first accept this. Accept W cycle is Q cycle. What is the reason, Devapam?
Since it is returning to the same initial state, so interchanging is
First law applied over the cycle. Q is delta U plus W, delta U cycle 0. And very good. So W cycle is Q cycle. Okay, this I should not. I'm splitting this. This is how much? Q1. Plus this is what adiabatic. You know what is the answer? 0. Adiabatic irreversible is Q is 0. You say anything? Okay, it's okay. Then move on. So Q adiabatic. I'm distinguishing this. This is also adiabatic expansion. Adiabatic expansion. Then next is what? Tell me Q2. Next is Q2. Still next is again adiabatic. Q adiabatic compression. I'm very close to finishing. Okay. About to finish. Adiabatic compression. I know you're tired. I know that. By what? Q1. Please. What is this value? Adiabatic, no mercy. No heat interaction reverse. Okay. So Q1, so simplified to Q1 plus Q2 by Q1. You note this very much. N cycle, this is the general statement. Generally true. Generally, universally true for any cycle. Universally true for any cycle. For any cycle, reversible or irreversible cycle. Any cycle, reversible or irreversible. I'll take up from this point, but this never forget. You start from Q1 plus Q2. You understand what is Q1, but Q1 is what? Answer this. High temperature, heat interaction. Q2 is what, sir? Low temperature, sink temperature, heat interaction. Can you tell me it is positive or negative? Positive? Q1 positive? Q2? Negative. Good. Q2? Negative. Why? Q2 is the Work done on compression. Compression is what? Work done on the system is negative work, and Q likewise is negative. Means heat rejected from the system into the surrounding, withdrawn from the system. Expansion is one, compression is another. Expansion, you have to put it, system gets it, and compression system rejects it. So negative. So Qt is negative. That must mathematically also. Happy? Okay. 5 minutes. I'm over. Achha. Just applying to the reversible cycle. That is a stop. Applying. Shall I? Applying to a reversible cycle. Reversible cycle. What is Q1? This I'll stop here. Maybe I'll repeat this point again. But let me finish satisfaction. Q1 is what? You know very well. You're smart. N moles ideal gas. Just Q. What is the expression? Tell me. nRT ln V2 by V1 sir. Q is W. nRT ln V2 by V1 sir. So can I write on the top nRT? T or T1? T1. So T1 is the temperature. ln V2 by V1 plus 0 plus 0 plus, okay, 0 I should not write. Q2 is what? This one Q2 is what? Tell me nRT. Similarly, this is also isothermal. This is also isothermal. nRT2 ln V4 by V3. Happy? I say too much actually. See, nRT and people. This is clumsy. Oh, sorry. What I'm writing? For reverse cycle, I'm writing. What I'm writing? Q2, Q1. See, eta cycle. Sorry. Right here, nicely. Q1, right? nRT ln V2 by V1. Nicely right. Next one, nRT1 plus nRT2 ln V4 by V3. Final man. V4 by V3. Okay, so and then denominator nRT1 ln V2 by V1. Do you know that what is V4 by V3? Yesterday I demonstrated. V4 follow. V4 by V3. See. It was shown. V4 by V3 is nothing but V1 by V2. It was shown through the adiabatics. Okay, it was Tp to the power gamma minus 1. V4 by V3 is nothing but V1 by V2. So can I write here? V4 by V3 is what? V1 by V2. If it is ln V1 by V2 means what? ln V1 by V2 is minus ln V2 by V1. V1 by V2 ln V1 by V2 means minus ln x is minus ln 1 by x. ln x is minus 1. So quickly write this out. So you write this one more extra line. ln V2 by V1 minus nr T2 ln V2 by V1 happy by all V2 by V1. So you have a good cancel nr happy ln V2 by V1 cancel. What remains? That's it. This is for reversible cycle. This is generally. So this is cycle right here. Cycle reversible. That's it. We stop now. Okay. Reverse cycle is T1 minus T2 minus 1. From this I will start next class. From this then we'll proceed. Okay. Next class. Okay. We'll consider the further discussion next class. Thank you very much with these words. Okay. We have actually called it. Okay.